All right, we want to figure out a concrete example of how to actually implement what we figured out in the last couple videos. In particular, if we've got two jointly continuous random variables x1 and x2, and we define these new random variables y1 and y2, y1 is the sum of the original two, and y2 is the difference. Let's find a formula for the joint probability density function for y1 and y2. All right, so first, I want to identify g1 and g2, right? These functions of x1 and x2 that somehow give us y1 and y2. So g1 of x1, x2 is going to be x1 plus x2, right? And then we can say that y1 really is g1 of x1, x2, and g2 of x1, x2 is x1 minus x2. All right, this is just so we can put it all in the language of what we talked about in the last video and actually get up to the point where we can implement this formula. So we get this. We want to figure out, right, we need to verify two things. First of all, we need to verify that the system here, y1 equal to g1 of x1, x2, and y2 equal to g2 of x1, x2, actually has a unique solution. In other words, a unique pair x1, x2 that gives us y1 and y2. So we need to verify that first, and then the second thing we need to verify is what I was calling point 2. We need to verify that this Jacobian of g1 and g2 is non-zero. All right, so we want to solve the system y1 is equal to x1 plus x2. That's g1 of x1, x2. And y2 is x1 minus x2. All right, so let me first take the second equation and say that this means x1 is y2 plus x2. And if I then plug that into the first equation, this leads me to, right, in the first equation we would have y1 is x1, which is now y2 plus x2 plus x2, and solve for x2. So y1 minus y2 over 2 is x2. All right, and now do the exact same thing to solve for x1. You know, for instance, we could plug in up here. So we could say, you know, if x2 is y1 minus y2 over 2, then from this first equation in blue that is, right, just using this and that together, well, this will tell us that x1 is y2 plus x2, which we can write as y1 minus y2 over 2. Right, and so we've got y2 minus 1/2 y2, so this is really y1 plus y2 divided by 2. All right, so let me move the problem statement here and summarize what we just found. All right, y1 equal to x1 plus x2, y2 equal to x1 minus x2 has the unique solution x1 is right there, y1 plus y2 over 2. x2 is going to be y1 minus y2 over 2. All right, so we verified the first point. Now we need to verify the second point, which, let me keep my definitions of G G1 and G2 up there. We need to verify the second point, which has to do with the Jacobian of G1, G2. All right, so second, we need the Jacobian, which again is going to be the derivative of G1 with respect to x1, derivative of G1 with respect to x2, derivative of g2 with respect to x1, derivative of g2 with respect to x2. And fortunately, in this case, these derivatives are actually really easy to calculate. Partial of g1 with respect to x1 is 1. The partial of g1 with respect to x2 is also 1. Partial of g2 with respect to x1 is 1. And the partial of g2 with respect to x2 is negative 1. And so what we end up with here is negative 1 minus 1, or negative 2. So we can now utilize that second point, which said that as long as the Jacobian's non-zero for every single x1 and x2 that we care about, we can say something positive. In particular, we could say this. Well, that is true here, right? It's equal to negative 2 everywhere, so it's not equal to 0 anywhere. And what we can finally say is that f sub y1, y2 of y1, y2, well, this is going to be the original joint PDF f of x1, x2 of x1, x2, oops, divided by the absolute value of that Jacobian. And so this is exactly the original PDF just divided by 2. Now, you might say to yourself, this doesn't make a lot of sense, right? In practice, this doesn't make a lot of sense because the left-hand side depends on y1 and y2. The right-hand side depends on x1 and x2. So, how do we make this nice and consistent? Well, we use the fact that we know what x1 is in terms of y1 and y2, and we know what x2 is in terms of y1 and y2. So this is going to be the original. Let me just rewrite this as maybe 1/2. The original PDF of x1 and x2, that is. And here we're going to have y1 plus y2 over 2, y1 minus y2 over 2. Right, and now the left-hand side depends on y1 and y2, the right-hand side depends only on y1 and y2, and everything is consistent. Right, and again, it boils down to the fact that we have this unique solution, x1 and x2, in terms of y1 and y2, and so we can freely rewrite them in terms of one another. That's what makes all this work.